So today what we're going to be working on is simplifying cube roots with variables. Okay, so I want you to take a look at the try this, which is simplifying square roots that have variables. Remember, so I'll write this down for you. You can write it down on your paper. When you are simplifying square roots, so write this down, remember. Perfect squares, variables, have an even exponent, and to find the square root, divide exponent by 2. Okay? All right, so give that a try and then come back and check your answers. Okay, so let's take a look at number 1. We have the square root of x to the second, y to the fifth. So I noticed right away, since it is a square root, I see x squared. So x is actually a perfect square because the exponent is even. It's divisible by 2. So I'm just going to put that on the left side, x squared. And I have a y to the fifth. So the perfect square that goes into y to the fifth. Remember, start working backwards from 5. So you go down 1, y to the fourth. That's an even exponent. So it's going to be y to the fourth times y. That gives me y to the fifth. So we have the square root of x squared is x. Divide the exponent by 2. The square root of y to the fourth is y squared. And then we have the square root of y. All right, so let's take a look at number 2. We have negative 3/4. The square root of 80, a to the third, b to the seventh, c to the fourth. All right, so we're going to bring down the negative 3/4. Actually, let me use a different color here. So let's use green here. Negative 3/4. Sorry, I didn't give you guys enough room here. All right, the perfect square that goes into 80 is 16 times 5. A to the third, the perfect square would be a to the second. And a on the right side, that gives me a to the third. B to the seventh, the perfect square would be b to the sixth, and b. And then we have c to the fourth. That's actually a perfect square because there's an even exponent, so we'll put c to the fourth over there on the left. So now let's simplify that. Sorry, I'm going to go over here now. Okay. So we have negative 3/4. The square root of 16 is 4. The square root of a squared is a. The square root of b to the sixth is b to the third. Remember, divide the exponent by 2. The square root of c to the fourth is c squared. And then I have the square root of 5ab. Okay, multiply negative 3/4 times 4, that's negative 3. Then we'll have a, b to the third, c squared. And then the square root of 5ab. All right, so now let's talk about perfect cubes that are variables. Now remember, perfect cube comes from multiplying a number by itself 3 times. All right, so let's start with x to the first times x to the first times x to the first. Let me write that a little bit better. All right, so x to the first times x to the first times x to the first. Remember, when you multiply, you add the exponent, so it's x to the third. X to the second times x to the second times x to the second is x to the sixth, right? 2 plus 2 plus 2 is 6. X to the third times x to the third times x to the third is x to the ninth. x to the fourth times x to the fourth times x to the fourth is x to the 12th. Hopefully you're seeing a pattern now. X to the fifth times x to the fifth times x to the fifth is x to the 15th. So hopefully you see here that, look at the exponents that I'm getting. 3, 6, 9, 12, 15. These exponents are all multiples of 3. And that'll always happen. So let's write that down over here. So a perfect cube I'm writing it sideways, sorry. Perfect cube has exponent is a multiple of 3. So I could keep going. I know x to the 18th is a perfect cube, x to the 21st, x to the 24th, and so on. Okay, so now let's do the cube roots here. The cube root of x to the third is x. The cube root of x to the 6th is x squared. The cube root of x to the 9th is x to the 3rd. The cube root of x to the 12th is x to the 4th. The cube root of x to the 15th is x to the 5th. Hopefully you're noticing that if I take this exponent that's underneath the cube root and divide it by 3, because these are multiples of 3, I actually get the cube root, the exponent, because this really is a 1, right? 3 divided by 3, the index is 1. 6 divided by the index, which is 3, is 2. 9 divided by the index is 3. 12 divided by the index, which is 3, is 4. 15 divided by the index, which is 3, is 5. So if I want to find the cube root, let's say I do the cube root of x to the 24th. I take the exponent 24 and divide by 3. So that's x to the 8th. So let's just write this on the side. Divide exponent sorry, I had to move something, by 3. So if I want to do the cube root of x to the 33, I know that's x to the 11th, because 33 divided by 3 is 11. The cube root of x to the 18th, well, 18 divided by 3 is 6, so it's x to the 6th power. Okay? All right, so now let's start simplifying. Let's look at what we have to do here. All right, so it says, find the largest perfect cube that divides into the radicand evenly. That's the number that's under the radical. Remember, your variables have to have an exponent that's multiple of 3. Make a factor tree. Put your perfect cubes on the left, your perfect cubes on the right. Take the cube root of your perfect cube and keep the radical and radicand. So make sure you have that little 3 in the index to represent a perfect cube. Okay, so we have the first one, the cube root of x to the 5th power. All right, so we have here the cube root. Make sure you have that little 3 in the index. So start at 5 since I have a 5th power and work backwards. 4 is not, right, so 5 is not divisible by 3, so it's not a perfect cube. Go backwards. X to the 4th, that's not a perfect cube because it's not divisible by 3. X to the 3rd, that's a perfect cube. Exponent is divisible by 3. So it's x to the 3rd times x squared gives me x to the 5th. The cube root of x to the 3rd, remember, take the 3, divide by 3. That's the index that's out here, right? And 3 divided by 3 is 1, so that's just x to the 1st. And then bring down the radical, which is a cube root. Don't forget that little 3 of x squared. All right, so let's take a look at number 2. We have the cube root of a to the 4th, b to the 9th. All right, so we're going to set up our cube root. So cube root, cube root. Okay, what perfect cube goes into a to the 4th? So a to the 4th is not a perfect cube. Start going down. The next one down would be a to the 3rd. That is a perfect cube. Times a, that's a to the 4th. b to the ninth. That is a perfect cube because 9 is divisible by 3. So I'm going to put it here on the left. Now we're going to take the exponents and divide by 3. That'll give me my new exponent. That'll give me my cube root. So the cube root of a to the third is a. The cube root of b to the ninth, well, 9 divided by 3 is 3, so it's b to the third. And then I keep the radical, the cube root of a. All right, so now let's mix numbers and variables. All right, so on the side here, let's write down, or on the top, I don't care where we put it, perfect cubes for numbers, right? So we have 1 times 1 times 1 is 1. And remember, all the negatives work too. 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. 6 times 6 times 6, 216. Okay, so that's good. All right, so let's break this up. I'm going to bring down the 5 here. Put my cube root. Cube root. What perfect cube goes into 32? Start with the number 32. That's 8. 8 times 4 is 32. Then I have an x to the third. It has exponent, that's divisible by 3. It's a multiple of 3, so that means it's a perfect cube. So I'm going to put it over here, x to the third. And then I have a y to the 7th. That's not a perfect cube because 7 is not divisible by 3. So we're going to start going down, right? Go down y to the 6th. Yes, y to the 6th is the perfect cube. 6 is divisible by 3, so it's y to the 6th times y. So I have 5 times, the cube root of 8 is 2. The cube root of x to the third, 3 divided by 3, exponent divided by index is 1. So that's just x to the first. Y to the 6 divided by, the 6 divided by 3 is 2. So it's going to be y squared. And then I have the cube root, don't forget that little 3, of 4y. Multiply 5 times 2, that's 10. Xy squared, the cube root of 4y. All right, so let's try number 4. Okay, so let me put those numbers back so we can see them. Let me actually have to rewrite them. So it's those perfect cubes are 1, 8. You should be able to see them on your paper. I'm just going to put them here so we can look at them. 1, 8, 27, 64, 125, 216. Okay, so we have the cube root. And notice I have a negative 375, so I'm going to put the negative underneath my perfect cube radical. A to the second, b to the sixth, c to the eighth. Okay, so let's start this off. Cube root. Cube root. Since I have a negative under the radical, I'm going to put the negative with my perfect cube. So what perfect cube goes into 375? That's 125. 125 times 3 is 375. Now, a to the second. A to the second is not a perfect cube because 2 is not divisible by 3. And 2 is too small, and there's no, if I start going down, I'll have a to the first. So there is no perfect cube that goes into a to the second, so I have to put it over here, a to the second. Can't simplify a to the second. 3 doesn't go into 2, not even with anything left over. All right, b to the 6. So 6 is divisible by 3. That means it's a perfect cube. So I'm going to put b to the 6 on the left. C to the 8th, 8 is not a perfect, C to the 8th not a perfect cube because 8 is not divisible by 3. So start going down from 8. C to the 7th, no. C to the 6th, yes. So we have C to the 6th times C squared. That gives me C to the 8th. All right, so remember when I take the cube root of a negative number, it's going to be negative. So the cube root of negative 125 is negative 5. The cube root of b to the 6, 6 divided by 3 is 2, so it's b to the second. And c to the 6 divided by, the cube root of c to the 6, 6 divided by 3 is 2, so it's c to the second. And then I have the cube root, don't forget that 3 inside the index, 3a squared c squared. Okay, so that's it, and we will practice some more in class tomorrow. Have a good day, everyone.